Hi, in this video I'm going to show you guys some examples of kinematics that's modeled by trig functions. Okay, kinematics simply mean the study of the motion of objects. Okay, and we talked about this um, when we first applied calculus to find out the displacement, the velocity, the acceleration of an object at any given time. And I hope those terms, displacement, velocity, acceleration, I hope those are not terms that you're unfamiliar with because we actually dealt with them before. Okay, the displacement function, I'm gonna go over all of them really quick. Displacement function is just um, the position of the object, the position of the object at any given time from the origin. Okay, so if the object is 2 meters east of where it started, then the displacement is positive 2. If the object is 2 meters west from where it started, then the displacement is negative 2. Okay, I hope you guys still remember that. Still remember the difference between displacement and distance. They are different. Okay. Now for velocity is just um, the change in displacement over the change in time, right? Or simply the first derivative of your displacement function. For acceleration, it is just the change in velocity with over change in time, or in other words, v prime, right? The first derivative of your velocity function, or it is also the second derivative of your displacement function. All right, the last one, total distance traveled. So since we're talking about distance doesn't matter if you're going to the east, going to the west, right? The direction does not matter, right? So for the distance, we'll always have this absolute value bars, right? The absolute value bars. So to find the total distance traveled using calculus between the time interval t1 and t2, what we do is we just find the definite integral from t1 to t2, and we are going to make the velocity function positive. If it's negative, whatever is negative, we just take that as positive. So the absolute value bar will do that, right? And we'll do the definite integral with respect to time. All right, I'm going to pause the video, and I'm going to, when I come back to the video, the screen will be changed to an example. Okay. All right, so here is an example of kinematics modeled by a trig function. Okay, go ahead, pause the video, read the question carefully, and see what they want us to find. Okay, welcome back. So now we have a particle, and the particle is moving in a straight line, in a horizontal line, and the displacement is in meters, and the displacement function s of t is 5 minus 2 cosine 3t. Okay, the t is in seconds. Okay, for part A, they want us to find the particle's velocity and acceleration. So for velocity, for part A, velocity is just equal to the first derivative of my displacement function, right? The first derivative of my displacement function, which is just equal to, so if I differentiate 5 minus 2 cosine 3t, if I differentiate the 5, it's gone, right? It becomes 0, so I have 0 minus 2. If I differentiate cosine 3t, I'll get negative sine 3t, alright, negative sine 3t, and that's only the trig function, and I need to differentiate the 3t, right? That's a linear function in there, so multiply by 3. So my final product, my v of t, my velocity function, is simply negative becomes positive, 2 times 3 because it gives me 6. I have 6 sine 3t. Okay. Now, so for my acceleration function, which is just the first derivative of my velocity function, right? First derivative of my velocity function. So I'm just going to differentiate what I have here, right? I'm going to differentiate that. So 6 stays there. If I differentiate sine, I get cosine of 3t, and the whole thing multiplied by, if I differentiate the 3t, that gives me 3. So I have another 3 here. So the final answer will be 18 cosine 3t. Okay. Now, for part B, they want us to find the particle's initial displacement, velocity, and acceleration. Initial meaning when time is equal to 0, right? When time is equal to 0. So let me move down a little bit. Okay, so for part B, when time is equal to 0, so all you have to do is substitute t is equal to 0 for your displacement function. So s of 0 gives us, okay, 5 minus 2 cosine 3 times 0. 5 minus 2 cosine 3 times 0. Okay, bear with me, I'm doing this with the mouse. 3 times 0. So my answer would be, so cosine of 0 gives me 1. So 5 minus 2 gives me 3. Okay. My velocity function, when time is equal to 0, so I'm going to use, let me change the color, I'm going to use this expression right there, this one, right? And I'm going to substitute t is equal to 0 in here, right, in time here. So this is equal to, let me just write in red, this is 6 times sine of 3 times 0. So sine 0 is equal to 0, 6 times 0 is still equal to 0. So at the beginning, the object has a velocity of 0. In other words, it is not moving. Right? It is not moving. And finally, for initial acceleration, so let me move down a little bit more. Initial acceleration, let me use green. Acceleration when time is equal to 0. So I'm going to use the expression I have here, 18x cosine 3t. So 18 times cosine of 3 times 0, which is just 0. So 18 times cosine 0 gives us 18. Right, so that's it. Now we have the answers here. But it's good that we have found the answer, but it will be even better if we understand what we have just found. So at the beginning, when time is equal to 0, the object is about 3 meters away from where it was, right, from the origin, okay? And at that time, the object was not moving. It was not moving. However, it does have an acceleration of 18 meters per second squared. Weird, but that's what it is, right? An object is not moving, but it is gonna have an acceleration of 18 meters per second squared. Perhaps it will be even better if I have the units here. That will be 3 meters. This will be 0 meter per second, and this will be 18 meters per second squared. Per second. Some people do that. Okay. If you're not following, please replay this section. Replay this section, and if you have any questions, do write them down. All right. All right. So we still haven't solved part C and part D. We will go over that in class. However, I do want you to think about it, right? Think about it on your own. For part C, they want us to find when is the particle moving to the right, and when is the particle moving to the left, and when did it stop. Okay, so think about that. If it's if it is not moving, or if it stopped, am I going to look at my displacement equation, or am I going to look at my velocity, or am I going to look at my acceleration, right? Which one of them, displacement, velocity, acceleration, which one of them, or maybe some of them, what do I use to help me to know if the object is going to the right, left, or not moving, right? That's for part C. For part D, they just want us to find the total distance traveled. So you can go ahead, use the GDC, and apply the formula that I mentioned at the beginning of this video, and see what you get. Okay, so we'll discuss about C and D of this example in class. Alright, see you guys.